करना है क्या? ब्रॉडकास्टिंग है ना ऑलरेडी, स्क्रीन शेयर है, स्क्रीन शेयर है ऑलरेडी।
ये तो नहीं चाहिए।
हाँ नहीं तो जो भी है, अगर स्क्रीन शेयर है जो भी चलाएंगे वो ब्रॉडकास्ट हो जाएगा।
ये तो बस दिखाई जाएगा, आपने से नहीं चल रहा है ना, चल रहा है इस तरह। So a very good afternoon. After a heavy lunch, we have to start. But still, yeah. So this is the graphical user interface what we have developed till now of Brahmanudi. So first of all, we have to have a grid. Suppose if we want to run a model or anything like that, so we need a computational grid. Otherwise, we won't be able to where we perform our simulation. So we have to have a grid. So a grid can be like it can be anything that it can consist of x. It should consist basically of x and y, x coordinate and y coordinate. So here our aim is to apply our model to the real field basically. So what we aim here is that we should get the grid in terms of latitude and longitude. So that is our like main objective. So what we have done here is that we have to have one georeference image. So we will use that and we will generate the grid, and we will tell you in the process how to like generate the grid and merge the grid and get the whole computational results. But like what is being aimed here till now is that we want to get the flow characteristics such as flow depths, velocities, and all that within the river domain itself. Till now, the river inundation modeling has not been done, but it is under process. We have got some projects and we will do that also, but currently it is not under the scope of this particular workshop, so that we won't be doing. So our aim will be that we will simulate the model within the river ditch, so we won't be considering any inundations and all. So in different discharges, what can be the possible like velocities, depths, and all sorts of stuff we'll find out. Yeah, so we can click on the file. First of all, there we'll get the open menu of grid generator. First of all, you all can see here, then if when you will start doing by yourself, some of us can come there and we will be able to explain it. Yeah. So yes, we have to go to grid generator. Okay, so yeah, so this is the interface of the grid generator. So first of all, here we have to browse an image. The first step would be to browse an image. And as I have mentioned already, that the browsed image or the image that we will get, that should be an image which is georeferenced. The georeferenced image will only give us the latitude and longitude in the actual scenario. So we have to have a georeferenced image. And while we select that, while we click the browse, then by default it is GeoTIFF files. So we have to select this to be all files. Yeah. So then we have to go for the location, grid generator files. So some images this laptop has been given by them, so here it is not visible, but yeah, we can click the image and we can load the image.
If file won't GeoTIFF file won't,
the file should, yeah, any file will work, but it should be an image. It should be georeference. That's it.
Georeference.
Yes, yes.
GeoTIFF or anything?
No.
Once for that and then.
Okay. So Mm. That can be downloaded from any Sentinel website, so that then we can get the recent images. That can be done. So yeah, so this image can be get from any Sentinel website. Then image can. This is just an image. This doesn't contain any animations of it. Yeah. So next step is we have to assess that the river is flowing from which direction. Let's say a river can be flowing from north to south, east to west to east, or south to north. There can be four possibilities. So we can see the average direction of the river. So if we start from the upstream, suppose we are starting from the hilly terrain. This is the image of a Becky river, which is flowing near Manas National Park, which is UNESCO World Heritage Site also. So there has been a significant morphological change over the years. So this river has been considered, let's say. So here we can clearly see that it is flowing from north to south. So suppose we start from here. So we have to assign the direction north to south. Yeah. So we have to give the x and y values. The x represents the number of sections or the number of points in the x direction or the longitudinal direction, and y represents the number of lines or the number of points in the grid in the lateral direction. Yes. So here, if we consider, this is the longitude. So if we select as 10, let's say we select x as 10, so there will be 10 sections like this. It will be perpendicular to this. There are 10 numbers of sections. And then when we select y there will be 10 numbers of y's or 100, whatever it may be. The user can input. So let's say this is the user has to have an idea about what is the river shape. Suppose the river is somewhat like this and this. Then the length and breadth are almost similar. So somebody can just in that perspective. So in this section, so the width is very less and the length is very high. So we have to select as less, x as less. Let's say x is 10. Yeah. So from here to here, if we see that it will be around 10 times of that. X10, yes. Then the length is, this is x. We have given 10 verticals. Then in the direction of the river itself, it is somewhat 10 times longer. If we want to see here, see there is one more point here. The river is flowing from north to south. Then again, here we see the river is flowing from west to east. So again here we have to change the things, change the direction. So it is like that. So first of all, let's make from north to south. Yeah, and one more thing, and we can give it as 100, 100 or 80, or 100. Yes. Can you explain the logic behind about the 10 times? Yeah, actually, you see, the river is very narrow in this region, and the length is significantly higher. So because of that, we are looking at the grid. Yes. We had that you are setting. It is based on this image that is visible, or the entire image that we have put in this. Only that one. So see, you have given the big image, it's a big image. Yes. Zoomed in and for just for this section. For this section. So when we will be generating the grid and merging all the grids, we'll be moving in the suppose downstream, from upstream to downstream we have to create. So basically I have to, so if my river is very graded, so I have to go scene by scene. I cannot do it like one for a large area. No. Yeah. Is there any limit how much I can give with this? There is no limit. You can create. You can go on creating. Yes. Say the first portion, if the river is flowing north to south, then again it's flowing from west to east. Yes. So first we have to create a grids for the north to south portion. Yes. So when we zoom in, we have to focus up to that portion. Yes. Now it won't consider the entire image. No. Only the zoomed in. Only that. Only those latitude and longitude it will capture. Sir, these values are latitude and zone level. Yes.
your platform, you are telling it is 10 power 5, 10 power 6. This is your coordinates are not in the degree decimal units.
No, these are in UTM.
This is in UTM. Because whatever XY we are specifying, this is in UTM.
Yeah, later long will be getting in UTM. Yes, yes. Yes, yes. Yeah.
So is it mandatory for being this in UTM or I can work in WGS also?
No, it should be in UTM.
It should be in UTM.
But the DM, what that will come into later stages. Let's first focus on the grid generation. That this should be in UTM. The image should be in UTM. Yes, yes, yes. Yeah. Okay. So then comes the next step. First of all, we have made it like that while it starts, while somebody like want to make the grid, then we have to start from the left bank. Suppose you are standing in the direction of the river, then it should be starting from the left bank. The first line should be in the left bank. Then in the clockwise direction, we'll close the loop for the generation of grid. That will be demonstrated. Yeah. So we can go for draw polyline. Draw polyline. So the river is flowing from north to south, right? It is flowing from north to south. So this will be the left bank, the initial. So we can generate the grid like this, with a single click. Then one single click subsequently, we can generate the grid.
To understand it bit clearer, like I'm just trying to understand the overall picture. So
Yes.
what we are trying to do is we are just trying to define the bands of the
Yes,
river,
that's right.
and then we are trying to generate the grids within that bands.
Yes, yes.
So for our first for north to south, then for west to east.
East to east, it can be any direction. It depends upon the river morphology.
Should we take slightly outside the river bank or
You can take slightly outside the bank also, but when you will be providing the surfaces and all, that will come into later stages. Like it is up to you. Like you want to generate the grid for which region. If you want to generate the grid for the outer region, it will give you the grid for the outer region. So if you start from here, then it will generate grid for those points also.
Now this way we have flow characteristics or the hydraulic characteristics will be computed only within the river.
Yes,
Right?
yes.
Now if we define it outside,
Mhm.
will it be calculated for
Yes, it will be calculated there also. There also.
for demonstration purposes?
Yes, yes. That is what I have told. Like now we have started working on this river inundations as well. That will come into the later stages. Not this is out of the scope of this workshop, but we are doing that. Yeah.
is there any control that option we can?
You can click backspace. Backspace, then these points will be deleted subsequently.
Like he is deleting.
He is deleting now. He is clicking backspace and the points are getting deleted. If somebody clicks like by mistake some point, then he can click backspace and delete. Yeah.
Do we have any advantage like we have managed digitizing, right? Now we have the open OSM maps, which gives the river boundaries, the flow boundaries again. We are getting the flow boundaries in the OSM map, right? Is it possible if we can import that directly into this and go for a grid generation? Like, how would that look like? Is it possible?
Only the boundaries.
Only the boundaries. Now the what he is drawing it manually. So now this is a bit time taking process, right? If you want to do it for a large scale river. So in that case, if we have a polygon which defines the boundary of the river, we can directly
Only the polygon.
yes.
Yeah, that we have to.
Yeah.
We can note it down. Somebody can please note it down.
Now, polygon wise also you can do. Just you draw one, direct one line.
I mean, like instead of
No, he's telling demarcating the boundaries.
just directly drawing the boundaries
From the image to directly import. Just it is a snapshot. I mean, just clipping kind of things you are talking about. When you complete this one, like
Yeah. So
Anna,
this is
I think it is the second part of first part. Demonstration is going on first. So after that they will be doing hands-on. So now not necessary that you will parallelly do it. This is what I feel.
Yes,
Achha,
yes.
just 1 minute. One minute. 1 minute. No, just 1 minute. I think because after that you will be also doing hands-on. So first you go through the demonstration, then you do the hands-on. Otherwise, all will be different pace, and you will be all are doing different things. So he cannot continue there. So what will be good that let him demonstrate the thing, then we will again do it, and then everyone will be doing it, and they will be down. That will be good. So first they have drawn one line from there to here, one polyline. That is from the left side of the river. Left side of the river. And in the flow direction, then you go to the left side and then next you.
Yeah. Now we have to go in a clockwise direction. Suppose we have to close it like this. We have to double click, and then we have to start on from this side.
From any side.
Basically, you can draw from here also, but this line should be drawn. It can be started from here. There is no problem, but that loop has to be closed in. You cannot draw this line and then this line. This line has to be drawn. You can draw from any direction. You can draw from any
in a
direction.
clockwise.
This is the fourth line. So after this, we can generate a grid. Yeah. So grid has been generated. If you can see, you can zoom in also. Yeah. So this is the grid, computational grid. So in all these points, the simulations will be zoom out. Then we have to save this. Yeah.
Just sorry to interrupt you.
No problem.
So, like, can we do it like this, or you want to accumulate the questions and take it later? How
No problem.
No, you can keep on.
Yes, madam was trying to.
That was an error or something. Like, can we make a manual change?
Manual we can save, like it will be saved in Excel. So in Excel, if you want to little bit change, then we can change in the Excel and we can do that. But here in the after generating this grid, in the drawing part you can't change as of now. Drawing part you can't change, but you'll be saving Excel. So in that Excel you can make a little bit change if you want, as per your study computational domain or study area. If you have that much of practical knowledge, that how does it goes.
And suppose if you don't want the last line. Let's say last line is not as per. Then you can just manually delete the last line.
In the Excel, and you can again browse those X and Y, like where you have saved the Excel, and you can you can just
So you
upload.
also have a labeling or a numbering for each and every grid.
Yeah, we have in Excel we have labeling.
So you will basically get an
Excel.
We will show you.
We'll show you that.
That way it will be more clear.
One question, after this also, can we withdraw the polyline by changing the number of X and Y?
Yes. Why not?
And
Yes.
you will override those files or you generate new?
It will generate new, but like if we want to combine suppose we want to model from here to somewhere downstream, then we have to combine different grids and then we have to generate. So likewise, he's asking on top of this. Yeah, we can.
If I now change the X and Y numbers, then it will override this existing.
If we don't save it, it won't be affecting anything. This is just a visual representation.
Suppose if I give X and Y with 20 and 50 and click on generate grid, keeping this polyline the same, okay, will the grid be overwritten or it will create a new grid?
Unless you
It
save
will.
X, Y.
This is just the like grid. We haven't saved it till now.
Okay.
There is no question of like overwritten or something like that. It's like that.
So once we grab the demonstration,
Then we'll be able to properly like tell. Yeah. So coming to the next, yeah, we have to save it first. That is good.
Is there a way to like find out the orthogonality check?
Orthogonality part I'll come. Everything will come. Yeah. So second we have to like generate suppose this grid. Then we have to change the direction at first. Suppose west to east. Actually, ideally speaking, if you generate the grid, it should like somewhere in here. it will be more better than that way. So like we have terminated it here, but if we generate till here, this is also kind of north and south. So if we change the keep the influence point inflection point over here, then we can go from there, and there also we can change. No, not necessarily, but we can do that. But when we do from west to east, now the grid will generate like this. So we need more x and we need less y. So we have to change the y to 10 because this have to be constant for merging. This 10 sections has to be for merging. Lengthwise we can take any number of points, but that same number of like sections has to be there. I hope it is clear. Yeah. So please change code. Not to sub को ऐसा बना दिया. Hmm. 10 दिया तो 10 दी दिया. 20 दी दिया.
Any direction again we have to the second sub
And then while we generate one more grid, then we have to save and replace. Then it will keep on adding. Why?
the same
Why?
The Excel also will show.
Replace.
Now the accumulated grids are saved.
Yes, accumulated grids are saved now.
So it will be a combined.
Combined grid. So then we can go from east to west.
west.
Or west to east.
West
sorry.
to east.
Yeah. 10, and then we can give some around like 80. Drop polyline again.
Is it necessary to define the X and Y and then start drawing the polyline?
Yes.
Does it have significance?
Yeah, I think
Or
so.
the polyline just takes a polyline and takes the X Y into picture?
No, it is not like that. We have to specify.
First X Y then draw.
Yes.
Now, because in a river continuously, the whole river, this along the flow line grid will have to be same number. Then only this will be merged.
Otherwise, that merge
suppose
won't be
somewhere
done.
you are going by, then you different number, so that will go. So this is important. Lengthwise, how many division you are making, that is not the problem. But widthwise, the division will have to be same.
West to east. Left side is this one.
West to east general. And while we draw the grid, it should be somewhat smooth. It should not be that erratic and all.
Environmental form environment of one other.
Circle में intersect कर. सलवार से जाओ.
This line should be inside the other.
Yes. And This line should be somewhat, these two lines should be somewhat like similar. Then only the
And it
margin
should
will
be at
be.
least inside,
Otherwise,
not
one grid
outside.
will be elongated. Otherwise, one will be very compacted. So if it is similar, then margin is better. Yeah. Again, we can replace. Axis. So again, we have to go from north to south. Let's say we create the grid till here. So till 10, and then until let's say. And we have to make sure that this line should intersect properly. So let's say we have prepared grid for this particular reach. Just an example. We have prepared the grid for this particular reach. Now when we want to see the grids in a single place, then we have to browse the final and then browse the final YY. Then we have to just merge the grid. Yeah. So we get the whole grid in a single place. Intersect no one.
Taking the intersection. Intersection is important. Otherwise, this will be important.
Intersection of the golden.
Yeah, it is going outside actually. So yeah, that's good.
एरोको चेंज कर काट को लेके रखी
কাট
कोड बनाना एक कोड बनाना
ডিলিট করে দিন
follow कोड लाना. So yeah, this problem came to us now actually. These problems comes due to bad intersection. Suppose one intersected line is there, the other intersected line should be like properly placed in parallelly, kind of very near to that. Then this problem doesn't come. Maybe that problem came now. It is actually good for that this came from our side. You can also get this problem if we do it in a better way. Then this problem doesn't come.
You see, in other things it is not happening.
Yeah.
This is grid is going. It should be inside the other, but parallel.
Okay. Can only delete the video.
Can we go back from here? Like, can we delete that part?
Yes, there are ways. Like in Excel that we can do.
Yeah.
In Excel we can.
So if we do say like we want to remove only the bottom portion, now we already have this Excel sheet. Now let's say I create a separate grid only for the lower portion.
That is
save that as a difference. Yes.
That is good.
So it's better you keep on
Saving in
saving all
each
separate.
Then you have to like save everything in a separate. You have to make a copy of it.
Copy,
Best you can
so
make.
in case you goes wrong somewhere in the last grid, so you
Just replace
just
that.
Replace that.
replace the last one.
That can be done.
এটা রেকটিফাই করে দিব আপনি ডিলিট করে দিন আবার
You have to delete for it.
And a separate.
These portions are merged. That is like okay. Thinking about it. GS opera. This Excel, that is nothing but suppose we generated till some point and
এটা
and
মার্জ
then
করিলে
again
গুচি
we
যাচ্ছে
have like started from a particular
এটা
merger
মার্জ করে
line.
দিই গুচি
So this doesn't do anything. They keep one line out of
এইটো
those
পোরশন
two
আকোবাৰ ড্ৰ
lines.
কৰি ৰেক্টিফাই কৰি
Then
দিম
merge the grid. That is what it basically does. Suppose there are two lines when we make the grids. One line has been made. Then again, if we close the loop, one more line has been made. So these two lines cannot be there at the same place. So they like the code does in such a way that only one line is there and then grid has been merged. It is like that.
How is the selection being done?
It is like based on the like best fit that is being done. That is like that.
Most
Grid size has
Most nearest basically.
grid size has to be like more or less equal, right?
Yes. That is why you cannot like put any spacing between those two lines. Those two lines should be very close to each other. Then only they can remove one line and in based on the nearest like points or the that deletes one line and then merging like that. So yeah, it came for two reaches.
now I think considering the time to do the entire thing should be problem.
It will be.
Now you can
They can start like doing.
no, whether you do be generated. So okay, then they can now start doing also. What time it is there?
It is till 5 I guess.
5. Okay.
Yeah. So better we should like and in the schedule some regeneration problems are given for tomorrow also. So we want to like proceed today itself some of the stuff. If there is some problem, then in the first half to tomorrow some hands-on can continue and then we'll be able to clear the doubts. That would be better. I feel like that. So yeah. Then suppose we have generated the grid. The first step is being done. So to simulate the model, the first and foremost we should have the grid. We are having the grid. Then we should have the bathymetry. That means the
one thing you said about this saving those files separately.
Yes.
Then at the final stage in the browser, etc. Then how we have to merge them?
Then you can manually suppose it's some till some reaches you don't have any problem. So you can keep till that reach. So you can like use the other portion. Like suppose the last portion. That last portion you can take and merge with that. That can be done. So if we have the basically in a nutshell you have all the fragments and then you have to manually merge. This grid is doing automatic merge.
You can do it in Excel.
Yes. No problem.
This is
Yeah, that if we open the file, the last has been like the last selection what has been done is been already like selected there, so you can directly do it. Yes. So yeah, so we should have the bathymetry or the bed for the flow simulation, and that can be obtained from the DEM. In the previous versions of Brahma, we didn't have any provision of DEM, but now we have that DEM upload option has been integrated in this version of Brahma, and then DEM can be obtained from two ways. One, we can directly download, and then we can like get the elevations which are in land, but we can directly get the elevations from. But some portions are water, so we cannot get the elevations of the blood level beneath the water. So that is one important one that Sapani ma'am has also told at that time, that the water surface will be getting will get the DMs where the water surface will be flat. We won't be getting the DM within the water surface. So first of all, let's upload the DM. If we have the DM which is from survey dataset, we have the cross sectional data, then we can easily create a DM. Easily means it can be easy for us, but like if you want, then we can give a demonstration on that as well. Basically what we do in a nutshell, if I want to say that in an ArcGIS, suppose you want to create a DM, then you can create a shape file on the right bank. Suppose a small strip on the left bank. Then if there are any sandbars, then you can mark the sandbars and the keep the water portions like you cannot mark the water portions. So then from those shape files we can like select some random points, and then if we have the cross sectional data we can merge all the points together with the cross-sectional data and all the shape parts, extracted points and all, then we can generate the DM by using any natural network algorithm or any other algorithm, and we can generate the DM in ArcGIS. That can be done. But as a modeler, that is already there with us. That can be done. So if we have the DM, we can upload the DM. Upload Becky DM. Yeah, DM successfully loaded and stored. That message will pop up once it gets uploaded. Then, yeah, then we can extract the elevation. Yeah, this 32646 is this is basically UTM zone. 46 is UTM zone and 326 is the code for northern hemisphere. And 3 to, if we go for consider the southern hemisphere, then it would be 327 and the and the zone where the river resides. That can be like that can be obtained from an internet also. Then that can be like input given as an input here itself. Then you click OK.
Connection is
So the elevations are being saved in Excel.
successfully.
We have created the grid, we have the DM, and we can zoom in also. Yeah, so we can see all the points are there. All the generated grid points are overlaid with the DM itself. So all the points from the DM are being automatically extracted from the DM itself to the corresponding to the grid points. So that has been done. And then we can see the cross sections also. Suppose we select a cross section, select line for cross section, and if we want to see the cross section of any line, suppose that line, we click, and then the cross section is obtained. That cross section is would be visible like this. So cross section. Yeah. So this is the cross section in that. So here we can see that this is flat. This is basically, so this means that this is water surface, right? So this is the water surface. This is the raw DM basically. We don't have survey data for this. We have selected this site. We have also not done any survey, so we have selected such site that can be like done in real time. So we also haven't done the bits and all for this cross sections. We also don't have survey data for this. So yeah, this is the cross sectional points. Yes, sir. So yeah, this till this process or till this step we have to do if we have the original D. Suppose we have constructed the DM from the survey data, we already have the web profile, then we have to perform simulation or we have to perform the grid generation or the steps which are explained till this step. We don't have to go further. This is the last step. So we'll get the cross section, all the elevations and all will be stored. So that will be done. Then, if we don't have the survey data, then we have to have some logical arguments. So we have to have some logical bathymetry that comes beneath the constant flat line. So what is being done here is we are like fitting some parabolic shape like bed beneath the water surface. This is not just like a simple parabolic shape that is like center it is maximum there and some parabola is being fitted. It is not like that. Suppose there is a terrain there is a terrain, one slope is like this, there is one slope, this is very steep. Suppose while the river goes in a meandering shape, then obviously in the outer bank there will be more depth, inner bank it will be less depth. So if we see in the natural rivers as well, then we can see that in the outer bank or the inner bank where the depth is less, the subsequent slopes are also very flat. If we see, the bank is like cliff shape. If we see, the bank is cliff shape on the outer bank. Suppose the bank lines where the water surface has been meeting. From the, if we see the next subsequent point, that will be on the higher elevation as compared to the other. So what we do, we see the next point. Or if the next point somehow falls below that point, there can be some possibility. Suppose a grid is there. Suppose a grid is of 30 meter. There is a big river, we are modeling the river, then it can be of 30-meter resolution. Like 1 point to 1 point, the delta axis or delta y is 30 meter. Then suppose there is one water surface is there, then it can rise a bit and then again it can fall. In real case scenarios, again it can fall. So it is not that if it is 30 meter that the next grid point can come in the below region as well. It may not be like on the top. If there is a board, then I will be better to explain. But still, board is not here actually. When board এখন কাম নেই Okay, I will try to explain. Suppose flat line is there. Some the obviously the banks will have higher slope in the land area. There is a water surface slope, then some points will be on the higher side. So what we are doing, we are like drawing tangents, like we are doing tangents from the subsequent points. But the condition is that the next point should be higher than that particular point where the water surface is there. That point should be on the higher side. It cannot be low. Then the tangent will go upwards. I hope you are getting. Yes. Is this clear?
If you
I don't think so.
PPT, and if you take a PPT here,
Yeah, I'll try to. I thought that it would be a
find a Brahma that there itself you can create a blank page.
Blank page and also.
You just insert a blank page.
Hmm.
Now we can take a pen.
Yeah.
You just go to display. Just go to presentation. Now you can take a go below.
Just from there.
There bottom.
Pen.
Pen. Here you take a pen.
Pen.
Whether it is hand also maybe working.
This is I think touch.
No. Sometimes that or not. That one is
Yeah.
touch.
Yeah. See. এটা গুছাই কেনেকে ঠিক আছে so yeah
The rubber is there.
Rubber is also there. Okay.
Rubber is there. That other one is rubber. No, after paint there is a this is rubber. No. First
Oh, whatever. Suppose, yeah. Right click. No? I forgot.
Will be there.
I don't use
No,
that.
right click. Then there should be a rubber also.
Okay.
Or you do undo.
I'll do. Suppose we have the DM like this. Sorry, the cross section basically. Yeah. Okay. So let's say the water surface is this.
Keep. Now go to that. Display. There should be a rubber.
Yeah, that's what. I don't know. Again, we have to select pen again. Yeah, this one is the eraser.
This one is the eraser.
Okay. Suppose this is the water level. So this point is already known. Then suppose if this is on the higher elevation, suppose this is the next grid point, and this is the next grid point on this side, or this is the next grid point on this side. So what we are doing, this is on the higher elevation, this is on the lower elevation, that means the junction. So we are trying to draw, this may not be straight line but consider as it is to be straight line. It will come like that and it will come like this. So we get a point, we get a slope basically. So what we are doing, we are fitting parabola in a manner that it goes in this particular slope.
Your line should have tangent is
Yeah,
wrong.
tangent is wrong, I am not able to draw properly actually. So this is the basic idea actually. Yeah, along this line, yes. So this is the basic idea. Suppose there can be one more problem in this.
Basically, you want to fit a parabola
According to the slope.
so the 2 points on the bank,
Hmm.
the tangent at that slope, the parabola should fit there.
That's what.
I can fit any number of parabolas in that.
Yes, yes.
From those 2 points with that tangent line.
The 3 points will be required.
Third will be is this
In that particular slope, the parabola will be fit basically. 4 points will be there, so accordingly you can fit. Suppose there can be some cases if it is like this. Suppose this is the water level, I am not drawing the other side. Suppose this is one grid, and in sometimes if the grids are coarse, suppose the grid doesn't fall here, it can come over here also. That is what I was trying to explain. It can come somewhere here also.
Being the
Yeah, it can come somewhere here also. Then we have to like see the next subsequent point. That is what we have done till now. Like the next subsequent point, it will see if this is like, if this is comes, if it is upper than that, then according to that slope it will fit the parabola. It is like that. But there is one more problem in here. Suppose the water level is very wide, the waterway is very wide, then if we fit a parabola, it can go very deep. That can be also a problem. So to solve this problem, suppose we have to have a basic idea of how much flow depth it can, like until how much flow depth it can go. Suppose some river is there, like one should know that maximum depth can be somewhere around 10 meters if this is the water slope, or this is the bed surface slope elevation. Or if somebody can like go in the site also, and we need not take any sophisticated instruments and all, we can take help of any like local person. They can like also insert something and they can measure the maximum depth, where by visualization we can see that if it is on going like this, then we can see where maximum depth can be. Or we can, from the shape of the river itself, we can have an idea where the maximum depth would be. So if we measure the depth there also, there, by using any sticks also, then suppose for many cross sections we do that. And or manually also, if we put, suppose we are not going there, we have an idea on in many of the cross sections we are putting just the, this is the maximum depth it can go. So we can specify that maximum depth in our code also. Yeah, so this is the maximum depth. We have to restrict the depth that it cannot go beyond that. So like that we have to restrict. Suppose this is hilly terrain. If we put, let's say 5 meters. Let's say 5 meters. Somebody know it is 5 meters. Then we have to extract the bathymetry.
is it the maximum of all the cross section or because the depth will be different at
Yes, yes. It is the maximum all. Yes. It cannot go beyond that 5. Maximum it can go is till 5. After
he is asking whether it is the maximum depth of a particular cross section or the entire river depth.
No, but entire. It will be applicable to all cross.
It will be applicable for all
cross sections. In later stages, if we want to do, we can do by like section by section, or we can like manipulate the battery in the Excel itself. Or after everyone does, we can apply some smoothing functions also, like Gaussian filters and all. We do in Google Earth Engine also. Those things also can be incorporated to smoothen out the bathymetry. That can be done. So yeah, then bathymetry will be extracted, additional data stored successfully, so that profile will come, then final bathymetry profiles. Yeah, the same menu will pop up. 46. Okay. No, 46. Hmm. Select cross section. Very good, very good. Plus to
Village surface package.
थोड़ा सा मिलेगा बहुत 5 to 9.
Oh, it was again.
Yeah, here we can see. So this is the what we have got from like raw DM, and this is the obtained bathymetry from Brahma itself.
What is the elevation of the blue line? 105.
Yeah, the blue is the DM data, raw DM data,
Yes,
and this is the fitted bathymetry.
the elevation is around 105.
Yeah, so 5 meters till 5 meters it has like
For every section, they have reduced.
need not be. If the slope is less, then it may not lead to 5 meters.
Let's see some
May not be. Because it is hilly, the slopes are very high. If we take a alluvial river, then the slope will be less, then it would be 5. It won't be 5. And in some regions there can be.
So if it is less than that, then you can ignore kind of things also. If it is more than that, then it will take care. And if it is not otherwise not going very deep, then it will keep like that. This is not that high. This is within 3 meter or so.
So instead of doing all the manual effort, it will like reduce that effort.
Can we zoom to the downstream part? There is some sandbars.
There we have to like generate the grid and do the process. You can do it by yourself also now. Then we'll be able to see. But we also haven't gone through that. So we have just taken. Oh here. Oh here. Oh yeah.
Ah, yes, some sandbar.
Here we can see if there is some sandbar. Select line for section.
Or right side.
Last 3-4 process. Last. Yeah.
That part is actually sandbar.
This one was the sandbar portion. So here the depth is more. Is like that.
Can you see the DM image?
Image, yeah, sure. Image to record.
Image. This is from the right side. But on that, it is on the left side. The changes is from the left side, right? From the zero changes there.
Chain is the cross section to right. Last section, let's say for last. Yeah.
This zero is from the left side.
This one is the sandbar portion. This one.
But you can see if zero is on the left side, they have bent. That means it is on left side, right? Or top side.
No.
Yeah. If zero is this one, then sandbar is on should be here. Zero is
No. Zero is this side. In this side.
Zero is
In this side.
But we first started from the left side, right? We have made all that from left side. So like, how can you define that zero is always from on right side of blanket, but we are discharging on the left side of the blanket? Why is there a discrepancy here?
No. Our grid is that is the grid generator we are doing. But when we take a cross section, it is from this side to that side. Cross section is.
Cross section is taken from the right.
Right. Yes.
from if you can be reversed, then it will be easy to understand in the future.
Okay, sure. Take. Feedback to yeah, so we can now proceed for like some hands-on. Then it will be more clear, I guess. And one more thing I want to quickly, like we can generate one grid. We have the excuse me. We have the hello. We have the real mathematic data of suppose cyan liver for a very short. So there also we want to show you that how the elevation profile comes. Cyan liver. Ini baru rectangular rectangular. Next to effort here. 41 here.
Square है
41 here.
square कोई
না স্কোয়ার করি বহুত বাইরে
itu ভিতৰত
এইটো ড্ৰ কৰাটো একচুৱেলি আমি এইফালৰ পৰা কৰিলে ভাল এনেকুৱা চিকুৱেঞ্চত
ঠিক আছে মাজৰ সেকশনটা লৈ
এইটো অকল ক্ৰছ সেকশন দেখাব
মাজৰ সেকশনটা লৈ এনেকৈ ভিতৰতে ক্ৰছ সেকশনটা সিলেক্ট লাইন so we'll directly
this is the actual
if we have the actual
data we have
then we stop here we need not go beyond this is the actual cross section from the survey DEM. Okay, so we can.
Is there any study or any reference in which you have compared this actual mathematical data and the tangential method?
No,
no. This is actual data. We have also given input as actual data, and then because this is quite what we are attempting, that is quite challenging, and then different river will be having different kind of characteristic. So accordingly, that is just and this is no one has done it so far. We are doing it say for the first time. We are trying to have modified DEM. So this is just the first approach. Then we will have to check that for this particular river, once we have experience of this kind of lot of DEM, say we can have that this will fit this particular curve. Not say parabola means not always square or something. Other exponent can be also better fit. So that way we will have to see. And there will be in some river we can have several horizontal line in it. So there all these points will be different. Accordingly, we have checked that also. That we have checked that we are getting different at different point, different depth kind of things, depending on the side slope that is that is experiencing at that particular cross section. And for one river, Bekti River, we were trying, and that was more or less close to this one. But then it has a lot of if and then or that kind of things. So that requires some experience also, and where you will take the point and how you will. Okay, with experience, once you work on that, then any model, this kind of things, and it is of course quite challenging.
This is our first attempt, and we are like trying to do machine learning also. Like
That
if
kind of
we have a lot very good amount of data sets, then we can train some machine learning models and then can like at least predict something. That it may not be a unichannel always. There can be fluctuations also. Sometimes it can come. So you want to like fit a equivalent kind of channel. Because some channels are there, we are fitting a equivalent replacement of that. So these things also we are trying. This is just the first step, I would say. So a lot of work.
but then we do not suggest that you should go for bathymetric modification, rather you go for actual bathymetry. But from DM, when you are in a very interior area, you do not have anything, there you go for using this DM.
That's what.
That is what. That is. And this has come as a result of your queries only.
Yes, that I have mentioned actually last time.
That is the
A
good
ma'am from CWPRS actually suggested us that we can like include DM and we can do these modifications also.
So now
she specifically mentioned
also. Yeah.
she specifically mentioned this. So with her comments only we have included this. So we will be hopeful that some this time also some comments as yes sir mentioned that 1 0 that should be confusion. That also will include in the
Or
list.
simply just mentioning here.
Okay, something we will do so that there
Something will have to be
no
mentioned which is right, which is there.
Yes.
That is correct. You note down.
Okay, she is noting down. So we'll try to improve these aspects in the later stages. Yeah. Thank you.
And while drawing the line, we should always go in a
Perpendicular.
clockwise. Clockwise. Do not draw from upper side. You go this way, that way, this way like that. Clockwise. Always make the circle clockwise. Then it will be good for other people also. সেইকাৰণে কনফিউজ হৈ গৈছে সিহঁতক এইটো ক'লে ক্লকৱাইজ কৰিলে নাই ঠিক আছে
সেইটো মই সেইকাৰণে সেইটোতে আঁকি থাকোঁ একো নাই বাৰু
সেইটো কাৰণেও হ'ব পাৰে
সেইটো কাৰণেও হ'ব পাৰে
তোমাৰ জিৰ'টো ইফাল সিফাল হৈ যাব পাৰে
কিবা এটা হ'ব পাৰে
সেইটো এডাল লাইন টানিছোঁ হয় কিন্তু আমি লাইনটো জিৰ'ৰ পৰা কোনটো ধৰাই দি সেইটো ডেট কেন বি প্ৰব্লেম ফালৰ পৰা মানে ক'ত কোনটো প্ৰগ্ৰেমিঙত ক'ত পাক লাগি আছে ধৰিব
ফিক্স কৰা দিয়ে ফিক্স কৰি থৈ
তাৰমানে এইটো বডিটো এনেকে 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 আমাৰ সেইটো আছে তুমি এবাৰ ইফালৰ পৰা আঁকিলে বা সিফালৰ পৰা এনেও কনফিউজ হ'ব নহয় সিহঁতক কৈ দিয়া ৱাইল ড্ৰয়িং দ্য গ্ৰীড এতিয়া মানে তুমি এবাৰ যদি খিনিত আছে এটা গ্ৰীড আঁকি চোৱাচোন এনেকে এনেকে এনেকে
আৰু মানে ধৰা বস্তুটো যেতিয়া আঁকিছোঁ আমি
এটা চিষ্টেমত যাব
গ'লে মানে ধৰা এনেকে শেষ কৰি দিছা ন তাৰপিছতে পাৰ্পেণ্ডিকুলাৰ টাইপকৈ আঁকিব লাগে এতিয়া বেছি মানে গীত কৰি লাষ্টৰ বেকাটো চিধা তেতিয়াহে হ'ব গম পাইছানে সেইকাৰণে মই তোমাক কৈছোঁ লাইনডাল ইফালে কৈছিলোঁ সেইটোৱে লাইনডাল মানে যদি তুমি সেইটো ফ্ল'টো গৈ আছে ন যদি এনেকৈ আঁকা গীতটো এনেকুৱা হ'ব ন যে লাইনটো এনেকৈ গৈ আছে নদীখন এনেকৈ গৈছে একদম চিধা পাৰ্পেণ্ডিকুলাৰ হ'লে
লাইনটোৰ লগত মিলাকে হ'ব নদীখনৰ লগত মিলাকে হ'ব সেইটো লাইনত সেইটো ক্ৰছ ছেকশ্যনত মিলাকে হ'ব নহ'লে মানে বেকা কৰি দিলে বেকা হৈ যায়
নহয় এইটো মানে হেৰি বেলেগত ক্লিক কৰি দিব নোৱাৰে সেইটো অলপ প্ৰব্লেম হৈছিলে কিন্তু মানে সেইটো আগতে
If I do this,
তুমি এনেকৈ এটা আঁকি চোৱাচোন সেইখিনি জেগাতে আগৰ যিটো ৰাখিছিলা তাতে তুমি কোনটো চেনবাৰ থকা যে সেইখিনি সেইটো নহয় চেনবাৰ বিকি এইখিনি তুমি তেনেকৈ আঁকি চোৱাচোন এইখিনি আছে হয় নেকি আৰু ওপৰৰ পৰা আছে তুমি এটা সেইটো নদীখনৰ সদায় অৰ্থকণালী তেতিয়া হৈ গ'ল তেতিয়া সিফালৰ পৰা এইফালৰ পৰা সদায় ক্লক ৱাইজত আকৌ ইফালৰ পৰা ক্লক ৱাইজ বেকাকে কিয় ক'লা এনেকৈ যোৱা তুমি সেইখিনি মানে ইয়াৰ অৰ্থকণালী নদীখনৰ সদায় ক্ৰছ ছেকশ্যনটো পাৰপেণ্ডিকুলাৰ সেইটো ইষ্টটো চিলেক্ট কৰিছিল ন ৱেষ্ট ঠিক আছে এক্সটো দিব লাগিব আগৰ পৰা যি দিছিলে তেনেকৈ দিয়া এতিয়া তুমি মেট্ৰিমেট্ৰিক চাব লাগিব মেট্ৰিমেট্ৰিকটো আনিব বেটিমেট্ৰি চেম বেটিমেট্ৰি লৈছিলে নহয় হ'লেও এটা চিষ্টেমত গ'লে ভাল
মই মানে স্যাৰ এনে পইণ্টছ কেইটা এইটো এক্সট্ৰা যেতিয়া আমি ফিক্স কৰি দিওঁ সেইকাৰণে মই মানে যোনফালৰ পৰা ইউজাৰ আঁকে মানে
যোনফালৰ পৰা
ভুল নহয় এইটো ফিক্স কৰা আছে x1 টো এইটো হ'ব x2 টো এইটো হ'ব x3 টো এইটো হ'ব x4 টো এইটো হ'ব তেনেকুৱা ইণ্টাৰছেকশ্যন পইণ্ট কেইটা আমি
লেফ্টৰ মানে
ৰাইটৰ পৰা
ৰাইটৰ
পৰিছে মোৰ মানে অভ্যাস হৈ গৈছে মই মানে ৰাইট
আগতে আমি তেনেকৈ
আঁকিছিলোঁ হেবিনেছ থাকিব
এইটোৰ লগত ইমান এটা কথা নাই
ফিক্স থাকিছে পইণ্ট চাইড ইণ্টাৰছেকশ্যন পইণ্ট
কিন্তু চেঞ্জ কৰিছেতো সেইকাৰণে তোমালোকে বুজি পেলাই যে কিবা এটা কৰিলা
এইটো বেটিমেট্ৰিত আহি গৈছে আপলোড কৰাৰ পিছত
সেইটো
মডেলিঙৰ ক্ষেত্ৰত আছিলে আৰু ইয়াতেও চেঞ্জ কৰা গৈছিলে আগতে এই ক্লক ৱাইজ ডাইৰেকশ্যন নাছিলে আগতে আমি ইউজাৰ মেনুৱেলত লিখি দিছিলোঁ এইটো ডাইৰেকশ্যনত এইটোৱে হ'ব লাগিব এইটো ডাইৰেকশ্যনত এইটোৱে হ'ব লাগিব সেইটো চেঞ্জ কৰিছোঁ লেফ্টৰ পৰা আৰম্ভ কৰিলে হ'ল ডাইৰেকশ্যনৰ লেফ্টৰ পৰা ক্লক ৱাইজ
Just go with the GIS. You can also
That was the basic idea.
Now we are doing it now. Instead of that, I draw what is here. Say here that the line that actually replaces with the excess pen one maybe nobody knows the number maybe excess like this. Excellent. Why I suppose this is only valid. This is only valid. We are if it consider then what I have mentioned is like this. Right? See, on that so if you are other side, that side, they reaction which should not really matter. I will land. One side. That's correct. That's correct. When we suppose we want to calculate the direction of the first of all, what we are doing in the model is first of all, by which then we are get the coordinates. We need to have the model. So we can in the start of the session, yeah. Tomorrow you see the first and using the CM we have so there we can start the steps like regeneration to the so इसी वो 10 दिन आप अगर
Now we are doing the integration study. So there we are doing from the outside also. You can do from the outside as well. You are from IIT.
Or that problem is there, the first thing that problem is there, then give you to me, then it all functions. Because they take a different location. That will be there. If mine also is there everywhere.
Hello, there is a tea break, so those who want tea can go downstairs. There's a tea break downstairs. अच्छा तो आप लोगों को पीछे जाके बैठना था लेकिन मैं बोल बोल के मतलब
पूरा ये सिलसिला सुनूंगा मेरा को अरे हमारा एक वेबिनार डिबेट किया था ना वेबिनार चला पता नहीं आपकी अभी जनवरी से पहले मंथ फरवरी डब्ल्यू का जो
ओ अच्छा
उस टाइम से मतलब
अरे वेबिनार मत बोलो मतलब प्रोजेक्ट वाला इसमें अलग अलग वो लोग वो क्रिएट कर रहे हैं अलग अलग टीम क्रिएट कर रहे हैं पैरेलल चैनल्स क्रिएट कर रहे हैं फिर मर्ज कर रहे हैं चाहिए सर और आपका मैंने बोला कि कल ले लेना फॉर्म सुबह अगर आरएनडी से तो स्वतः ही तो साइन चाहिए और बैंक डिटेल्स और स्वतः ही साइन चाहिए आज ही अगर ले सकते हो तो
ৰাতিপুৱা মই ক্লাছ ক্লাছ আছে
মই 10টা বজাত আৰএনডি গৈ তাৰপিছত জৰ্ণি কৰি আহি
আজিও কৰোঁ
প্ৰথম তাত 4টা বাজিছে এতিয়া নাপাওঁ 5টা বাজিছে এতিয়া লাহে লাহে নোপোৱা হ'ম आरएनडी का ऑलरेडी
नहीं 5 5:15 तक मिलेगा 5 5:15 तक मिलेगा ही
अभी 4 तो बज ही गए ना
नहीं लेकिन आज का सर फॉर्म मिलेगा तो आज के साइन का
आज तो कोई इफेक्ट फ्रॉम दिस डे तो আমি দি দিম you submit the form from
वो जो सर का डेट अगर रहेगा तो तुम डेट लिखो कर सर साइन कर
কাল का डेट लिखो মানে আজি
ঠিক আছে কিন্তু কাম মডেলৰ
সেইটো জইন কৰিবলৈ আহিলে গাড়ীখন থাকিব কালি মই নাহিব
Final level അതിന്റെ സബ്ജക്റ്റ് at least one like
इसमें स्टोर नहीं करते, इसमें स्टोर नहीं करते, नहीं कर रहा है इसमें नंबर ऑफ पॉइंट्स, नंबर ऑफ थोड़ा थोड़ा अलग हो सकता है, पास में होना चाहिए।
Sir,
कोई भी अपनी मर्जी
can I stop the
पास में होना चाहिए।
can I stop the live
Yes,
stream?
yes, yes.